Hello students, welcome to Educate. We are going to solve the numericals from 9.10 onwards. In previous lecture, we have studied the numericals till 9.9. Now let's read the question. Question says, in the previous problem, means in 9.9, if 15 cm of water and a spirit each are further poured into the respective arms of the tube, what is the difference in the level of mercury in the two arms? So here information is given. Now further what happens? So what will be the height of water column and what will be the height of this methylated spirit column, and then we will find the difference. So let's see, we have found the specific gravity of methylated spirit. So now question is simple. So we consider like this, and here we take that mercury is imbalanced. Suppose here it is, there is little difference between the two levels. So this is the difference in level. Up to here it is in this column, and here there is slight difference. This is H. So you can, and here till this level there is methylated spirit. So you can say that pressure due to methylated spirit plus pressure due to height H of mercury column, H height of Hg must be equal to pressure due to water column, right? So now what is height of water column? In previous case it was 10 centimeter and further 15 centimeter water is poured, so height of water column is 25 centimeter. So we can write 25 centimeter formula that we are going to use, P equal to rho Hg, right? So H is 25, so we can take everything in centimeter, it's not necessary to convert it into meter. So 25 into rho. So in that case, if we want to use CGS, then that is also okay. So rho, so CGS density will be what? Density of water is then 1, right? And then rho G H. So this is H we have written, rho we have written, G. In that case, G will be 980, right? So must be equal to pressure due to methylated spirit. So we have found the specific gravity of methylated spirit, and the height of methylated spirit is this time, earlier it was 12.5 and 15 further. So this is 27.5. So 27.5 into its density specific gravity we have found in previous question, it was 0.8, right? So rho, then G is 980, and then H is this much, plus pressure due to mercury. So height is H, then density of mercury is 13. It is 13.6, right, in CGS, and then 9.8. So here the question is simple. What is 9? Why 9.8? It should be, we are using CGS, so 980. So 980 will cancel out from each, and then whatever is left, that is simple. So we can easily evaluate. So this is 25, just multiply this. So you can get 25 minus 27.5 into 0.8 divided by 13.6 will give H, right? So it will come out to be 0.221 centimeter. Is it okay? I think you have understood the concept. Concept is very basic. Now, next question is, can Bernoulli equation be used to describe the flow of water through a rapid in a river? As we have already discussed that Bernoulli theorem is valid only when the flow is laminar or streamlined. If there is turbulent flow, in that case Bernoulli theorem will not be valid anymore. We have seen the limitations while proving Bernoulli theorem. We have assumed in the beginning that flow is not turbulent, so it will not be possible. Rapid flow, if there will be there, then in that case it's not possible. Does it matter if one uses gauge instead of absolute pressure in applying Bernoulli theorem? See, if you remember, what do we use? Here we write P1 plus 1 by 2 rho 1 GH1 plus, sorry. Here not rho 1 GH1, it is 1 by 2 rho 1 V1 square plus rho, we can take a rho same, but here I am writing rho 1, then GH1 equal to P2 plus 1 by 2 rho 2 and V2 square plus rho 2 GH2. Here they are saying instead of P1, if they take what pressure? Absolute pressure. Though we have already studied two types of pressures. One is gauge pressure. Gauge pressure means actual pressure, ignoring the pressure due to atmosphere. So suppose we write here absolute pressure means P1 plus PA. Atmospheric pressure is also considered. Other things remaining same, equal to P2 plus PA and other things remaining same. So this PA, these two PA will cancel out. We will remain there. So we can do that. So question says, does it matter if one uses gauge instead of absolute pressure? No, nothing will happen. Here this term will cancel out and we will get the same result, right? Then there is another question. Glycerine flows steadily through a horizontal tube of length 1.5 meter and radius 1 cm. If the amount of glycerine collected per second at one end is 4 into 10 power minus 3 kg per second, what is the pressure difference between two ends of the tube? Density of glycerine is given, viscosity of glycerine is given, and you may also like to check if the assumption of laminar flow in the tube is correct. So we are not going to check that is over, but before that we will solve the question. So let's see. So here what we are going to use, here we have to find out pressure difference. So there is one formula that is called Poiseuille formula. Poiseuille formula tells volume per second. Q is given by pi by 8, which is constant. Then we take pressure gradient P upon L. Then we take force power of the radius. So force power of the radius and divided by eta, which is viscosity. This is the formula that we are going to use here. So we have to find out P. There is no problem. So let's first check whether all necessary information are given. Length of tube L is given, that is 1.5 meter, and then radius R is given. So it is radius of 1 centimeter, means you can write it 10 power minus 2 meter. That is okay. And then what more is given? Here the amount of glycerin collected per second is this much. Mass per second is given. Mass per second is 4 into 10 power minus 3 kg per second, right? And here Q tells volume per second. Keep in mind, here Q equal to volume per second, right? So what we can do, mass upon volume equal to density, right? So to convert it into volume, mass divided by density, if we write, then our purpose will be served. So here we can divide it by density to get that. That is okay, that we will do. And pressure difference to be found, density of glycerin rho is given in this. Density of glycerin, so here in this case mass divided by density, if we do, that we will get volume per second. So volume per second, that is Q, we will get, if we divide as 4 into 10 to the power minus 3 divided by density as 1.3 into 10 to the power 3. So we have got this much Q. And now what more is needed? Pi by 8 you can easily write. Pressure is to be found. That is okay. Length is given, radius is given, eta we need. Eta is given, viscosity is 0.83 Pascal second. Now we put the values and I think you can easily do. And after evaluation, what do we get? So P will be equal to, if you write the formula, rearrange the formula, so it will be 8 times L times eta divided by pi r power 4, and then after putting the values, your answer will be 9.8 times 10 to the power 2 pressure is in Pascal. Is it okay? You have understood? All values were there, only formula, Poiseuille formula was required in this question, although its derivation is not given in textbook. In NCERT textbook it is not given, and whatever we have studied like derivation etc. So I stuck to NCERT only. For more knowledge you can take reference of other books, but here our concern is just restricted till NCERT, so that is why I don't give other type of derivations. Although when I will start lectures for competition, I will touch every aspect. So let's go to next question. In a test experiment on a model airplane in a wind tunnel, the flow speed on the upper and lower faces of wings are given. Here what will happen? Here what they want to say. Suppose this is wing. So here pressure difference, here P1 and P2. If P1 minus P2 is greater than 0, here if pressure is more, then what will happen? If here pressure is less, then what will happen? If pressure is less, then there will be upward lift, right? So here our concern is upward lift. It means here speed should be more. If speed will be more, in that case, due to the concept, because of concept of Bernoulli theorem, what will happen? In that case, velocity will be more. If velocity is more, then pressure will be less, right? So there will be upward thrust. So here that upward lift, what is correct situation? P2 minus P1 should be greater than 0. It means P2 is larger as compared to P1, and then we have to find out force. So force will be P2 minus P1 into area, right? So our concern is to get these things. So let's analyze how to get. In a test experiment on model with plane wind tunnel, the flow speed on the upper and lower are given. So upper speed is, here speed is 70 meter per second, and here it is 63 meter per second. And if it is level flow, in that case, in case of Bernoulli theorem, these terms will involve 1 by 2 rho v1 square plus v1 must be equal to 1 by 2 rho and v2 square plus p2, right? So we can get pressure difference easily by using this. Like we take this P1 to right side, so P2 minus P1 equal to 1 by 2 rho, and then V1 square minus V2 square, and then we can get. So let's analyze, but first let's read. Here area is given. How will you use the area? So P2 minus P1 into area will give force, right? So let's put the information. Density is given. We can put rho here. So 1 by 2. Then this value 1.3. Then speed 70 square minus 63 square. So this will give pressure difference. And after that, you can put that value here, multiply by area to get force. And we have to find out the force, and that will come out to be, it is 1512.9 Newton. I think thing is clear. Now, there are certain figures. 9.20 AB refer to the steady flow of a non-viscous liquid. Which of the two figures is incorrect and why? So, what is required in such figures? Although we will see the figure just after it. Suppose figure is like this. There is a tube and there is another tube like this, and we say that here area is this much, but here there is constriction, right? If there is constriction, then what happens? Velocity will increase. If velocity increases, then pressure will decrease. If pressure will decrease, then definitely rise of liquid in column will be low, right? If pressure will be more, in that case height will be more. So this is basic concept that we are going to make use in this question. Let's see what is the figure about. So here there are two figures. In this case, what is happening? Here there is constriction, it means speed will be more, so pressure will be less, but rise in liquid is more, so that is wrong. In this case, what happens? Here at the constriction, speed will be more, so pressure will be less, hence rise of liquid will be less. So this one is correct. Now we are going to see next one. So next question says, the cylindrical tube of a spray pump has a cross section area of 8 cm square and one end which has 40 fine holes, each of diameter 1 millimeter. If the liquid flow inside the tube is 1.5 meter per minute, what is the speed of ejection of the liquid through the hole? So this simple question. So again we will see that there is no accumulation of liquid, and then we can evaluate. Cylindrical tube of spray has a cross section area 8 cm square. Now there are small holes. So from here and here, 8 cm square. That is 8 into 10 to the power minus 4 meter square, and here 140 fine holes, each of diameter this. So here area of one hole, or total area we can find 40 times pi into r. So radius is 1 millimeter divided by 2, 0.5 into 10 to the power minus 3 whole square. This is total area on right side, right? So here area is this much. So if we apply A1 V1 equal to A2 V2, so we will get the velocities if required. Let's read the question. Yes. So here rate of liquid entering is, the liquid flows inside the tube is 1.5 meter per minute. So you can write, apply the formula A1 V1 equal to A2 V2. So here A1 is this much, 8 times 10 power minus 4 into V1 is 1.5 divided by 60. Why? Per minute, equal to A2. A2 is 40 times this 0.5 into 10 power minus 3 whole square times pi into V2 is to be found. Now it is your work. I think you can easily evaluate V2, and after evaluation you will get, I'm writing the answer, 0.637 meter per second. Thing is clear? You have understood? There are 40 holes, so total area means area of one hole times 40. So total area will be this much, and speed in each. So it will be, we have assumed uniform, and hence we can evaluate. Now there is next question. Next question says, so we have reached on question number 17. So 17 question says, a U-shaped wire is dipped in a soap solution and removed. The thin soap film formed between the wire and the light slider supports a weight of this much, which includes the small weight of the slider. That is okay. The length of the slider is 30 centimeter. What is surface tension? So surface tension, what is formula? Generally, surface tension is given by force upon length. But since it is soap solution, there will be two surfaces. So we write F upon 12. And now we check what information is given. F is given, L is given. We can put the values. So it's your work. You can easily do 1.5 into 10 to the power minus 2 divided by 2 sub 0.3. You can evaluate. Now let's go to question number 18. Here, figure 9.21a shows a thin liquid film supporting a small weight 4.5 into 10 power minus 2 Newton. What is the weight supported by a film of same liquid at the same temperature? And figure explain your answers. So here, force and length, two things we have to consider, and in all three cases it is same, because L and surface tension, length is same, 40 is given, surface tension is same because liquid is same. So if we consider the formula here, F equal to, as we have discussed, F equal to F upon 2L is surface tension. So F equal to surface tension into 2L. And here they are saying that weight supported means F. So surface tension is same, length is same, because liquid is not changed, liquid remains same. So of course, in each case, the weight supported will be same. Now let's go to next question. What is the pressure inside the drop of mercury of radius 3 mm at room temperature? Surface tension of mercury at the temperature is this much. The atmospheric pressure is this much. Also give the excess pressure. So excess pressure we can find. So excess pressure inside a bubble, liquid drop is given by 2 times 2 sigma divided by the radius, where sigma is surface tension. So we can put the values twice of surface tension. What is surface tension? Given this much, 4.65 into 10 to the power minus 1 divided by radius is 3 mm. So 3 into 10 power minus 3. Just evaluate it, and that will be 310 Newton per meter square. Up to here there is no problem. Then we need total pressure. So just add atmospheric pressure. Total pressure will be excess pressure plus atmospheric pressure PA. So just add that value. So 310 plus, that is 1.013 into 10 power 5, and this will be in Pascal. You can evaluate. Now this last question. What is the excess pressure inside a bubble of soap solution of radius 5 mm? Radius is given and surface tension is given, And then question says, if an air bubble of the same dimension were formed at depth of this much, this is inside a liquid. In that case, what will happen? So let's analyze it. So here, what is happening? So we can say, I think there is some problem. So in this video, we have done till 10.19. Sorry, not 10.19, till 9.19 question. And the next question we will do in next video. Thank you for watching. Team Educate.